Hola, my name is Pamela. Welcome to my channel. Today I'm gonna talk about
Radiation pyrometers are based on the Stefan-Boltzmann law, which says that the intensity of radiant energy emitted by the surface of a body increases proportionally to the fourth power of the absolute temperature in Kelvin of the body. Here we can see a graph of radiant energy of a black body at various temperatures as a function of wavelength, and it is based on the Planck's law of thermal emission of radiant energy. In industrial temperature measurement, thermal wavelengths range from 0.1 microns for ultraviolet radiation to 12 microns for infrared radiation.
the emission coefficient or emissivity of a body is the ratio between the radiant energy emitted by a body and that of a black body that is at the same temperature and under the same service conditions. A black body is one that totally absorbs the radiation it receives and is a perfect emitter, and its emissivity is equal to 1. Bodies whose emissivity is less than 1 are called opaque bodies. The energy radiated by the black body is a function of its absolute temperature. For example, radiant energy emerging from a small opening in the wall of a uniformly heated room is not reflected, but is absorbed through innumerable internal reflections. This is the case in many industrial installations, where the pyrometer focuses directly on a furnace opening or on the end of a closed site tube. A radiation pyrometer calibrated for black body conditions will indicate a low focusing body temperature if the body is outside. The emissivity depends a lot on the state of the surface of the emitting body. For a metal like copper, it goes from 0.10 to 0.85 if the perfectly polished metal is abruptly covered with a layer of oxide, and the same happens with a liquid metallic bath. The pyrometer directed on an incandescent surface will not give us its true temperature if the surface is not perfectly black. That is, it absorbs absolutely all radiation and does not reflect any. In general cases, it is necessary to make a correction of the temperature read to take into account the absorption or emission value of the surface. Something to mention is that opaque bodies emit at a given temperature an amount of radiation energy that depends on the material and the shape of the surface. The body can reflect additional radiant energy coming from nearby bodies, flames, etc. So, if it has a low emissivity, it will reflect a large amount of incident energy, and if it has high emissivity, the reflected energy will be low. If the emissivity of the body is known, the receiver instrument is fitted with a device that allows the reading to be adjusted directly to the exact temperature of the heated body.
Here, we can see the emission coefficients of various substances located under these conditions. The emissivity of materials such as copper oxide, iron oxide, and nickel oxide is high enough to measure temperature very accurately without too many errors due to the parasitic radiation. Here we can see the variation of the emissivity in tungsten, which is widely used in filaments of incandescent lamps, according to the state of the surface of the samples and the wavelength of the radiation.
Within the operating waveband, the pyrometer cannot distinguish between the energy emitted by the body, the transmitted one, and the reflected one by other radiation sources. In a crucible containing molten glass, radiant energy emitted from the bottom to the walls of the crucible can emerge through the glass. If the crucible is opaque, its radiant energy is that of a black body and can be partially transmitted through the glass to the outside. Then, the radiant energy emitted will be composed of that of the crucible and that of the glass itself. In conclusion, radiation pyrometers measure the temperature of a body from a distance based on its radiation.
There are several types of pyrometer. The optical one, that captures light radiation between 0.4 to 0.7 microns. The infrared one, from 0.7 to 0.20 microns. The photoelectric detector that measures thermal radiation, the two colors or radiation ratio corresponding to two narrow bands, and the total radiation pyrometer, which measures all radiation emitted by a body. And I will be explaining all of them in greater depth in future videos. Coming soon.
And well, this will be all for today's video. Don't forget to give me a like, subscribe, and share. I upload videos every Wednesday in Spanish and every Friday in English. Adios! Bodies whose emissivity at solo temperature. If so, it has a low emissivity. So, if it to the walls of the cross